Hi everyone, so today we'll be talking about STEM through the ages, but more specifically, a topic that I find very interesting, women in STEM. So to start off, what does STEM even stand for? Well, STEM stands for science, technology, engineering, and mathematics. Now that we know what STEM actually stands for, we could just take a brief moment to have a thought of what the following items may have in common. So here we have solar panels, we have Kevlar, chocolate chip cookies, wipers, Wi-Fi, and medical syringes. Now, what they do all have in common is that none of these would even exist without the contributions of women in STEM. Though I'm sure many of us we already know the importance of women in STEM, this just further highlights the contributions that they've had in things that we've used day to day. So, beyond that, what do we think that the media or the internet says about the representation that they may be for, say, for example, a scientist? So, to find out, I put in the word scientist into Google Images and took a screenshot of the first results I saw. So, again, as I said, here's a screenshot of the images that I received when I put in the word scientist into Google Images. If we could just take a moment to make any observations and think about why these observations may actually be. So, according to my observations, I see that though there are men and women in these images, there do seem to be a few more men than women. These individuals also tend to be in a lab type of a setting. So clearly it is directed at a particular type of science. And finally, there is some diversity, which is good to see. Now doing a similar process, what actually happens when I Google the word engineer? Well, I did the same thing, but the results are a bit different. So, here I can observe, I see far more men than women in these images, and I also see a particular uniform and a style of dress that indicates you're a particular sector of engineering and is not encompassing the broad spectrum of engineers that we may have. Doing again the same thing with the word mathematician, here's what Google thinks a mathematician looks like. Well, again, similar process, but different results. We see far more men than women, and perhaps in some cases even less diversity and less inclusion. So again, those are the observations that I've made, but what observations can you make from the results of these searches? Maybe even try out yourself. And why do we think that these observations are in fact the case? Now that we know what Google and Google Images thinks of when I put in the word scientist, mathematician, or engineering, what sort of individual comes to mind when you think of a scientist, engineer, or mathematician? And how many of you actually think of a woman when you think of that? Now, seeing this all-encompassing sort of stereotype that may prevail in some of the Google Images we saw, how do we think that we as individuals are influenced by this sort of representation in society? Now, though Google in some ways in those images didn't show a very balanced representation, I feel like maybe we can discuss some women in STEM that truly deserve to be known. So, if anyone knows who this is, well, this is Chen Xiongwu, and though she's accomplished many things, here's a brief sort of idea of what she has been through and what she has done in her life. So, starting off, she very impressively has a PhD in nuclear physics, and during the process of acquiring her education, she did apply to the University of Michigan. Though she was given admission, upon knowing that women weren't actually allowed to use the front entrance at Michigan University, instead of still going on with her plans to study there, she actually changed her plans and attended the University of California, Berkeley instead. Though this may seem as a minor setback, actually it propelled her to many successes that she goes on to have, one being her contributions in the Manhattan Project during the World War II. Now, the Manhattan Project may be more well known as sort of the process of creating the atomic bomb. Her contributions in this was helping to develop the process of separating uranium metals into its various isotopes. Even more impressively, she's actually best known for conducting something called the Wu experiment, which essentially disproved a hypothetical physical law called the conservation of parity. Now, though this is a very complex law, what we do know is that her experiment paved way for several of our colleagues to actually go on and win the 1957 Nobel Prize in Physics, though, unfortunately, the Nobel Committee did actually overlook her contributions. So, here's a female in STEM that truly does deserve to be more recognized. Going on here, again, another woman in STEM who deserves recognition, and if anyone actually knows who this is. Well, her name is Shakuntala Devi, and very well known during the 1950s, she was also known as a human computer. This was because she could actually do immense mathematical calculations in just seconds. Now, though this is very impressive, this may not seem as very useful in the day and age of computers and calculators, but I can assure you that it was highly useful and highly sought after. Just to give us a bit of perspective, she was able to extract the 23rd root of a 201-digit number in just 50 seconds. Just to give us a bit of scope, it took the UNIVAC, which was the fastest computer of that time, 62 seconds to do the same thing. So she was faster than a computer by 12 seconds. Going beyond this, in 1982, she held the Guinness World Record for the fastest human computation when she was able to correctly multiply two 13-digit numbers in just 28 seconds. Again, very impressive. One of the stories about her that I found very amusing and interesting was one of her famous interviews on BBC during the 1950s. In this interview, the host asked her to answer a very impressive mathematical question, but upon looking at her answer, it was deemed incorrect. Now, after some short time, the host actually, upon rechecking their actual calculations, acknowledged that in fact the computer's answers were incorrect and Shakuntala Devi was correct. Now here we have someone who's a bit more closer to our time, and her name is Tiera Guinn. As a 21-year-old who hasn't even graduated from college yet, Tiera Guinn's already doing rocket science. So, as an MIT senior, she's actually helping NASA build a rocket, and reports say that it may be one of the biggest and most powerful ever made. As an aerospace major with a 5.0 GPA, she also works as a rocket structural design and analysis engineer for the Space Launch System that aerospace company Boeing is actually building for NASA. So these were three very impressive cases of genius-level females in STEM. Well, we do understand that women in STEM do not only exist in this capacity, and though these were very impressive, anyone can be part of STEM. Now, looking at how impressive these individuals were, we must ask ourselves, were any of these stories or individuals actually familiar to you? In fact, well, here's someone that you may be familiar with. Well, this is Rosalind Franklin. Well, Rosalind Franklin was well known for her working relationship with Wilkins. Well, Rosalind Franklin and Wilkins worked together on finding the structure of DNA, but due to personal conflicts, it led to them working separately. Wilkins later on moved to Cavendish Laboratories in Cambridge, where he met friends Francis Crick, who was actually working at the time with James Watson, and they were working on building a model of the DNA molecule. This being similar studies, unknown to Franklin, Watson and Crick saw some of her unpublished data, which was leaked to them by Wilkins. This included the very famous photo 51, as we can see below in the image. Essentially, this is a X-ray diffraction picture of a DNA molecule and was Watson's inspiration to find the pattern of DNA, which is a double helix, as clearly seen in that photo. Using a combination of Franklin's photograph and some of their own data, Watson and Crick went on to create their famous DNA model. Franklin's contributions were not actually acknowledged, unfortunately, but after her death, Crick did say that her contributions had in fact been critical. So, here's another woman that was not perhaps acknowledged as much as she deserved to be in some of her amazing discoveries. Now, why is Rosalind Franklin a special case? Well, she's a special case because of the GCSE curriculum. Franklin is actually one of the only 2 females studied in the STEM portion of the GCSE curriculum, alongside someone else we may know as Marie Curie. Now, this being brought to the attention of the media was actually dubbed STEMinism, and the lack of inclusion by the exam boards was heavily criticised. So we may ask ourselves the question, could we actually do a better job of inclusion than perhaps they can? Aside from the obvious, why is this important? Well, to me, STEM is all about problem solving, and problem solving requires a particular lens at which problems are tackled, and oftentimes this means that female predominant issues may be overlooked because the individual solving issues may not feel as personally engaged in these certain issues. Now, this is a generalization, but we can further delve into some sort of statistics, such as here we can see the percentage of female engineers. Well, female engineers are actually one of the lowest populated categories of all of STEM designations. Women actually only make up 14.5% of all engineers. Now, this is low, and it may seem low to all of us, but in fact, this 2021 June data is actually an increase from even earlier data in 2016, where women only made up about 4.6% of all engineers. So, over the years, we've seen a 25.7% increase. Here we can see this more clearly in the pie charts. On the left, we see 2016 data showing roughly 5% of women to 95% males, and newer 2021 data showing 15% females to 85% males. Though there is progress, we can clearly see that not only is there room for more improvement, there is such a great need for improvement. Now, looking at the percentage of female researchers, well, female scientific researchers only actually make up 30% of the workforce worldwide, as we can see in the pie chart below. But to remain some sort of optimism, when we're looking at the percentage of females in science professions, there has actually been some improvement and some hope, in fact. Women have reached the point of critical mass in the proportions that have STEM professional roles, where women actually make up 45.7% of the workforce. This is very close to the male proportions, and this does show in some ways a lot of inclusion and equality. Actually, in the recent years, even the inverse is happening, where the number of males in these professions is actually, in fact, decreased by 5,600, and women have actually increased by 4,000. So, despite this, what is the problem? Well, unfortunately, recent studies show that in 2021, during a girls' attitude survey conducted, 57% of our young members actually feel that STEM subjects are not for girls. And research actually shows that many girls believe that the added pressure of COVID-19 has even further hindered this development. So again, despite these statistics and despite these figures and despite the obvious, why is this an issue? Why does this affect me? Why does this affect you? Why does it affect everyone? Well, in some ways, this does mean that oftentimes we do end up living in a world that is some ways, in some cases, tailored more for men. Now, just a few examples of where this actually occurs. Voice activation happens to be 70% more likely to be accurate for men than women, and this includes even in cars. Now, it may not seem like a very big deal if Siri or Alexa cannot understand us, but in the grand scheme of things, in a world where technology and voice activation is becoming even more immersive and useful, this can be a very hazardous thing, especially with hands-free driving necessary, hands-free functions necessary in cars. Going a step further, when a woman is actually involved in a car crash, she is in fact 47% more likely to be seriously injured, 71% more likely to be moderately injured, and 17% more likely to die. Now, none of this data is to be alarmist, and we cannot attribute all of this to the lack of inclusion, but some studies do show that female drivers actually tend to be at greater risk, not just due to physiological reasons or something like that, that is unavoidable, unchangeable. Some studies even suggest that the fact that female drivers tend to need their driver's seat to be closer to the front actually may impact these results. Women needing their car seats closer to the windshield may be considered out-of-position drivers, where the actual natural general seating position for males is oftentimes considered standard seating position. Just to get a scope of what this means in the ergonomics of creating the safety of cars, standard seating position is optimum safety, whilst anything out of position may be considered less safe. Going a step beyond that, during the conducting of crash test dummies and tests for such things for cars, female crash test dummy models were actually not used as often in the driver's seat as male crash test dummies, and oftentimes they're placed in the passenger seat, giving us less data about the way female physicians and physiques may actually react to car accidents in the driver's seat. Now, though this is very serious information, we can take it even a step further when looking at medication. Well, as we know that there is a gap in the number of women in medical research trials as well as medical researchers. So, oftentimes this may mean that certain medicines may be more tailored to men. Now, though there are various reasons for why women may not be as included in some sort of research trials and drug trials and treatment plans, such as the risk of becoming pregnant or the fluctuation of hormones that may affect data. This also means that sometimes medicine does not take into account the specific times of a woman's cycle and how varied hormones may actually affect their treatment. A recent physician's health study, which actually concluded that taking a daily aspirin may reduce the risk of heart disease, actually was conducted on just 22,071 men and 0 women. Now, this is astonishing considering that heart disease is a very big illness that actually consumes many people. So, the lack of data that we have on women and aspirin and heart disease may be an issue, and it does make us question if we can generalize some of this data. A further 1982 multiple risk factor intervention trial, which actually investigated the dietary changes and exercises that may actually prevent heart disease, this was conducted again on 13,000 men only and no women. So it does say something about the data that we have and what we can do to sort of improve the data set. Between the years of 1997 to 2000, a fact that I found very interesting was that 10 prescription drugs were actually taken off the market by US Food and Drug Administrations. mostly due to severe adverse reactions that it caused in some of the individuals taking these drugs. But out of 10 of these drugs, 8 of them caused far greater health risks in women than in men. So many of these issues do actually affect women more. Not only are some medications not working as well for women, certain medications actually negatively may impact you. So, to draw this all back, how is this relevant to the curriculum and sort of the representation that we may have? Well, I believe that having more women being part of these fields will hopefully allow the female experience to be sort of part of the normal, rather than it being a mere consideration. Addressing these issues actually brings more equality, not just in jobs, but in our day-to-day lives. So, thank you for listening, and I hope that you found this as interesting as I did.